Hi, welcome back to Postgres for MySQL DBAs. My name is Dave Stokes. I'm a technology evangelist at Bricona, and we're looking at episode 8 on how to reclaim disk space for your server. This is something where it's very different than what you're used to in MySQL. We need to run a program called, or a process called vacuum. The official thing that it does is it reclaims dead tuples. I'll explain that in just a moment. In normal Postgres operations, tuples that are deleted or obsoleted by an update are not physically removed from the table. Think of it as throwing dirty socks along with clean socks on the floor. As the socks get dirty, they tend to pile up, and they remain until a vacuum process is performed on that table. Now, you do have to run vacuum periodically, especially on frequently updated tables. That's a recommendation from the Postgres documentation. Now, a tuple is Postgres' internal representation of what a row is in a table. So you can right now think that a row is equal to a tuple, and that will work. Now, MySQL uses a different MVCC system. Both are keeping track of various additions of the data. MySQL cleans up after itself on the way, where Postgres keeps them around. It's different, not better or worse. MySQL does this for you, and it does seem odd to have something called vacuum running on your tables to a MySQL DBA. It's okay. There's some good news coming. Now, the data in Postgres is stored in something called a heap. As I mentioned earlier, think of it as a teenager's bedroom where they have all their socks clean and dirty. The rows are stored in the heap by this object identifier number, also known as an OID. The data is not stored in any sort of order, and anything that is updated or replaced are kept in the heap until they can be cleaned up. Now, the OID is a 32-bit integer that can wrap around and cause all sorts of problems. So you need to make sure that every 4 billion transactions, or hopefully a lot sooner, the heap is vacuumed. Now, in this example here, we have this little table here where we have the ID column has one value for 2 and 2 for the value of 3. And this row here has been made redundant by this row. So we've done an update to this table, and now this table is not doing us any good. It's taking up space. Now, we can manually run vacuums to reduce this table to this table. There's also something called auto vacuum. So you most times can let that take care of you and vacuum up your dead tuples. Now, for example, what this looks like, we're going to create a table called foo. Very simple, an ID of integer, a value of integer. We're going to insert the first record, and that has the values of 1, 1. And then we're going to update that record where we're changing the value to 2, value to 3, and then value to 4. So we have 1, 2, 3, 4 rows of data that's gone in there, but actually in the table, there's only the one where the ID is equal to 1. And as of the last iteration, the value for the value column is 4. Now, if we go out and ask the system to tell us the name of the table and the dead tuples, it'll come back and tell us the number of dead tuples is 3, which were the first 3 rows the one we inserted in the first 2 updates. Now, if we type vacuum foo, it'll go out there and try the same query again. It'll tell us that all the data is current. There's no dead tuples taking up space. So remember to vacuum regularly. Postgres vacuum command has to process each table on a regular basis for several reasons. The first is to recover or reuse disk space occupied by updated or deleted rows. Also, it helps the statistics for the optimizer, so you'll get better query plans. Also, there's something called the visibility map, which speeds up index-only scans. Think of that as a shortcut to your data. Also, it's going to protect you against loss of the very old data due to transaction ID wraparound. It's a 32-bit integer. If you run out of transaction IDs, it gets very, very messy to try to get your old data or your new data out. Now, the visibility map I mentioned earlier is a very handy tool. Vacuum maintains this for each table, and it will keep track which pages contain only tuples that are known to be visible to all active transactions. I mean, this is the data that you know that's good and not redundant. Now, great thing here is that Vacuum can look through the visibility map and see if there's anything to clean up and what specifically it is. Also, in some cases, it allows the server to answer some queries using only the information from the index without having to dive into the data itself. So the good news is that the visibility map is smaller than Heap, so it's a lot easier for the system to go through there. Now, as I mentioned earlier, transaction IDs, also known as XIDs, will wrap around the MVCC that Postgres uses, checks the various transaction IDs, and once again, this is a 32-bit integer. So if you're doing lots of transactions, those numbers get used up fairly quickly. And that XID number will eventually wrap around to 0. When that happens, transactions in the past appear to be in the future, which means your data is going to need a very, very skilled person to be able to recover it. You probably have a catastrophic loss if you don't know how to do that. So to avoid this, vacuum the table in every database, at least every 2 billion transactions. I recommend doing it a lot sooner than that. Now, if you just run the vacuum without the word full with it, it simply reclaims the space and makes it available for reuse to the Postgres instance. It isn't turning it over to the operating system. Now, the good news is this command can operate in parallel, and normal rewriting should continue as this goes on. There's not an exclusive lock on the data. But once again, your operating system doesn't see this data. It's just kind of held in reserve for Postgres, which has its good uses and bad uses. Now, you also are able to leverage multiple CPUs in order to process these indexes. That's known as a parallel vacuum. Now, if you run vacuum with the full keyword on there, it rewrites the entire contents of the table into a new disk file with no extra space. This great thing here is that space is now returned to the operating system so that the server can allocate it as needed. Now, this doing vacuum full is much slower and requires an access exclusive lock on each table. This could complicate ongoing production, so be careful with that. As mentioned earlier, there is auto vacuum. Find out if it's running on your machine, type show auto vacuum. If it's on, it will tell you. If it's not, ask around and find out why it's turned off. Might be a good reason, a good learning experience. So that's the end of episode 8. It's been kind of crazy for the MySQL folks who don't have to worry about vacuuming their data, but it is a necessary thing to do with Postgres. And hopefully you'll be back for episode 9. And thank you. If you have any comments or criticisms or want extra content, please contact me at these addresses, and you can get a copy of the slides at speakerdeck.com/Stoker.